In this short video, we're going to talk about operating systems. Again, because this is an intro course, we're going to keep it very high level, but there are some basics that I want you to begin to understand so that when we talk about them in later courses, you're fully up on the step. So when we talk about operating systems, what I really want you to understand at this point is it's a program. It's just a program. Now, the kernel of the operating system is kind of the most important part, and that is what's loaded by the firmware when we turn on our computer. So the BIOS or the UEFI system startup tells the computer, hey, you're a computer, your hard drive's over here, here's your video card, here's the computer printer, all this stuff, right? And then it loads the kernel of the OS. The operating system, whether it's Windows, Unix, Linux in its 75 flavors, or Android or any other operating system in use, and even Mac, okay? Whatever the operating system is, once the kernel's up, it will then load the other software packages that it needs. You can configure operating systems so that you don't have to load everything, which can speed up your system as far as your operational performance because you're not loading a bunch of software that you don't need in RAM, which gives you RAM for other things. Now remember, your computer runs at a certain clock speed. So your computer doesn't run faster when you put more RAM in, okay? It's still running at the same speed, but you can hold more programs in RAM, which is faster memory, at the same time if you have more RAM. So the net effect is you're working faster, but your computer is running at the same speed, okay? A little side trip there for you. All right, so the operating system, it's software. Now, we talk about the North Bridge, which is your RAM, your PCIe, which is your video card and the CPU. All of the other stuff is via the South Bridge. Your operating system helps all of that get managed. Okay, that's all it is. It provides services to the applications that you're running so that they can do things with your system. Now, there's four big pieces, okay? And we're going to go through this briefly, but these are four pieces that you really need to know. Device management. We've already kind of talked about this. How do you access your printer? How do you access your Bluetooth speakers? How do you access the little card reader so when you take the chip out of your new camera, you can put it in and then use it, okay? All of that is handled through device management. If you've ever had to load a device driver, that's an extra little piece of software that's typically written by whoever manufactured the device to be compatible with whatever the operating system is that you're using so that there's a bridge in a communication. Your operating system will handle access to that device driver. That's why you want to keep your device drivers up to speed, because if you upgrade Windows or upgrade to the new Mac OS and your device driver is out of date, it might not be compatible with the new one because that particular printer manufacturer may not have updated it yet. So you got to kind of be careful there, but it's all considered part of the same thing. It's the operating system. Now, the second big piece is file management. Well, this is your files, right? This is your Word documents, your images, your audio, whatever it is you do on a computer, your program files, your source code, all of those files you need to be able to create new ones, copy them, move them, delete them, duplicate them so that you can modify them and have a different version. All the stuff we do with files, that's handled by the file system, including how do I look them up? How do I sort them? All right? That's all file management. Now, memory management is how is all of this RAM or virtual RAM on my hard drive, if I run out of RAM, how is all of this managed? Because in Windows, for example, I can hit Alt-Tab and flip between programs very quickly. Well, that means a different program is going to take up more of RAM, and I don't want my Word document and the RAM it's using to be corrupted by other RAM from a different process, okay? I don't want collisions. I want isolated sandboxes that can move in and out of RAM as necessary based on what I need to do. So the operating system handles all of that memory management. And that's no small task, okay? Because if I take something out of RAM for a few seconds, I better be able to put it back, right? I better not corrupt the files, otherwise the operating system is just not doing its job. Okay, Process management. If I load 15 programs because I've got a bunch of RAM and I'm doing a lot of different things, and there are times that I've got at least 8 programs up that I'm using heavily. I've got 2 different browsers, Premiere Pro, Word, Excel. I do this a lot. Now my system, my development system has 32 gigs of RAM, which is great. I can open up a lot. The problem is, what if one of them jams? I don't have to restart my whole computer, right? So I need to have a way for the operating system to say, hey, this particular application went south. Hey, processor, kick it off. Just terminate it, okay? So that I have an ability to keep going, if you will, without crashing the whole system. And that is handled by the process management aspect of the OS. Now, processes are all given what's called a PID. If you ever hear me say that, I'm talking about the process ID, which is basically the code that says this is his version of Word that he's running. Okay, and that changes every time you load the application. All right. To get the processor's attention, there's 2 ways. There's hardware, which is a keystroke or Control-Alt-Delete, something like that, where it's actually, or the printer sends a hardware interrupt that says, out of paper. Okay? There are hardware interrupts that get the processor's attention so that it can do what it needs to do to react. There's also software interrupts. When I terminate an application that's jammed, that is a software interrupt to the processor saying, this PID, kill it. Don't run that application anymore, okay? And then the processor has a way of talking to the operating system by setting what's called a trap. So if I'm running an application and I did a divide by 0 that I shouldn't have, the CPU can say, whoa, AOS, this particular process ID just did a division by 0. I ain't doing that, okay? And so then the operating system takes that error and it goes through an entire stack of handling, basically for someone to come back and say, divided by 0, don't do that, kind of a thing. So that you can handle errors gracefully and downgrade, again, without crashing the whole computer. So, how do we get the processor's attention? Through either hardware or a software interrupt. How does the processor set an error state? Through what's called a trap. Okay, last thing we're going to talk about, authority. This is pretty simple, guys. You either have root or supervisor authority, which is like I go to Walmart and buy a new laptop. I open it up, install it. I can do whatever I want on the computer, including delete the entire operating system, turn it into a brick. That is supervisory or root level access. I can do what I want. Most people operate at root access. What I try to tell people to do is when you buy a new computer, go in as root, set the password to something different that's a good password, then create a user that's your first name or whatever what you like. I had one student whose call sign was Dark Lord. Okay, whatever. Give yourself a call sign, whatever. But basically have a username that you like that is your user account that you do your normal daily activity in. And you can give yourself permissions to do what you need so that you're not hampering yourself. But if you corrupt that user environment or those user settings, you can log out, log back in as supervisor typically, and recreate it. As opposed to if you go in as supervisor and have full system rights and wipe out your operating system, you're kind of out of luck. You got to rebuild. Okay? In school systems, I'm sure as students you guys have seen, you can't do certain things on your school computers. Right? That's because system administrators who have supervisory access have locked you out as a user. Now teachers can do more, but even teachers can't do all of it. Okay? And so you can have different levels of user access, different configurations of permissions, but if you're root, you can do it all. Got to be very careful of that, especially in Linux and Unix, because you can really wipe stuff out if you don't know what you're doing. Okay, and that's true of any operating system, to be honest. All right, so the last thing I want to talk about is, I'm going to make kind of a minor point here for an intro class, but some assembly language is still found in operating systems. You can't get away from some of it. But more and more, as we want software and OSs to be compatible across a wide variety of hardware, more and more of the operating systems are written in C and C++. because those languages allow you to compile for different hardware configurations if you need to, or compile for a given CPU so that even if it's on different configurations, it still works. So because of compatibility, we've kind of moved up from assembly language wherever possible into a C++ type environment in order to give us that compatibility. So that's kind of a programming note. You may talk about that in some of your college courses in operating systems, but for now, just understand it used to be all assembly language. That changed pretty quick as they started coming out with modern operating systems, and now most of it's in C and C++. All right, what we're going to talk about next in another short video is the file system of an operating system, because that's one that that's one of the four that I really do want to focus on a little bit. So I'll see you on the other side.